Hello everyone. So in this video lecture, we're going to take up the two important concepts that go by role of consensus mechanism and your DLT ecosystem. Let's just go ahead with this. So let's just come to the consensus mechanisms, right? Their role. So consensus mechanisms, we all know are the rules, the procedures by which nodes across the distributed ledger, across the DLT systems, agree on validating of transactions. And the key aspect, I would say, of DLT is determining which user is going to validate the next block. And it is achieved by implementing one of the many possible consensus mechanisms. We've studied about proof of work. We've also seen proof of stake in detail. We've also seen Byzantine fault tolerance in detail. We know about delegated proof of stake and so on and so forth. So for permissionless DLT networks, there are generally many nodes because there's no permission required to join up the network, no authorization, no access. So there are generally many nodes competing at the same time to validate the next block. And hence there are many types of consensus mechanisms, with the most common being proof of work, proof of stake, and your Byzantine fault tolerance. And we are going to take each of them one on one in the upcoming slides. Let's start with proof of work. In proof of work, we know a node validates the next block by being the first to solve a computationally intensive puzzle which requires a huge amount of energy consumption. And the solution to this puzzle is the proof that you have performed the work. And if you have performed the work, your probability of proposing the next block, of being the person to propose the next block, becomes directly proportional to the global hash power that you have, becomes directly proportional to the work that you've done. So the probability of validating a new block depends on the instantaneous computational power devoted to the task. As a reward for validating a block, the node will receive a certain amount of crypto assets in the form of transaction fees or transaction fees. Let's come next to proof of stake. You already know all about these algorithms. It's just a, refresher to them. So proof of stake is a consensus process where an existing stake in a particular in a particular distributed ledger system is used to reach the consensus instead of solving energy intensive puzzles. And proof of stake is based on the idea that since users must invest directly into a particular system to participate in consensus, they're more likely to want the system to succeed. And very less likely that they will want to subvert it because they're invested directly into the system. For example, stake is often an amount of crypto asset that the DLT network user has invested into the system. And the probability here also depends on for how long have you been holding that DLT asset. Nodes participating in the POS consensus mechanism are rewarded by receiving the transaction fees included in each block they're the first to successfully validate. And then we also have delegated proof of stake, which is yet another approach to POS, where a set number of nodes are elected or selected to function as a block producing full validated nodes for the network, making the other nodes a little delegated. Byzantine fault tolerance in DLT systems, Byzantine faults may occur due to the abnormal functioning of the nodes. And the BFT based, that is the Byzantine fault tolerance based consensus algorithm, has been designed and implemented to solve this problem by ensuring that the distributed ledger system, it's actually functioning even with the abnormal nodes around. So what happens here, we want all the nodes that are there in the network to participate in the consensus process, which involves performing multiple rounds of voting and communication. We've already seen this in detail. And hence, when you want all your nodes to participate, it is good for smaller networks where you have a limited number of nodes. Additionally, since BFT requires that all participants agree on the list of participants in the network, the protocol is normally only used in your permission distributed ledger systems. Makes sense? Now comes the important part of this video lecture, that is the ecosystem. So ecosystem, DLT ecosystem is actually a collection of all the stakeholders, you may say organizations, you may say users, and in conjunction with all the other entities, and all of them have actually a role-based division. So there are four aspects of a DLT ecosystems, and these four aspects cover different people in it. We have hardware aspect, business aspect, software development aspect, and the protocol development aspect. We will be, touching each of them one on one. So let's just start with the hardware aspect of DLT ecosystem. Zooming in on the hardware side of the DLT ecosystem, because at the end of the day, your distributed ledger actually lives on the machines, right? So the first thing that very when I think of technology, when it comes to my mind, is machines. So let's just see into a machine. The ecosystem is made up of a large number of nodes. Each node can be computer, can be server, can be storage device, and together all of them are going to function together to form the blockchain network. And there are three main types of nodes you'll come across. So let's just see the first type. We have three nodes as block producing, non-block producing, and partial or light nodes. Now, what are block producing validating nodes? They are the most powerful participants. So they're going to actively take part in your consensus. Like they will help decide which transactions are valid, and they will also store up entire copy of the ledger, entire replica of the ledger that includes every single transaction from the very beginning. Think of them as your judges and record keepers of the network. And then you just come to the next one, that are non-block producing full validating nodes. And these nodes also store a complete replica of the ledger, but they don't participate in your consensus process. Instead, their role is more about verification. Their role is more about, redundancy, ensuring that the entire data stays accurate, stays available, even if your nodes fail. And then we come to partial or light nodes. These are your lighter to go participants. Don't store the entire ledger. Instead, they only keep a partial list of transactions. But to stay reliable, they must connect to the full nodes that are actually, they just act up as the a front desk for your full nodes. And your full nodes have the entire history. They are actually there for providing you the accuracy on the guarantee. And these nodes, your light nodes, they're just like the lightweight clients. They're faster, they're less resource heavy, but they're also dependent on your bigger nodes that are at the back end. So overall, whether it's your block producers validating nodes, your non-block producers nodes, or your light nodes, partial or light nodes, all of them are going to play a significant role in keeping your DLT system secure, in keeping your DLT system decentralized and efficient. Now, let's just talk about the hardware and infrastructure that is needed in a permissionless DLT system. In a permissionless network, the doors are always kept open. Anyone can just come up and create up a node. But also there's a catch. Each node must provide enough processing power, enough storage capacity to keep up with the network. The more nodes we have, the better the system is distributed among different stakeholders. And this broad distribution lowers the risks of fraud, risks of errors, even system failures. Because if you have to invade the system, you need to get 51% of the nodes on your end, and 51% of the nodes. If this nodes is a greater number, 51% also becomes a greater number. So you need to do more power. So all these nodes are connected together, forming a single synchronized network. But to make this possible, the system needs something very important, and that is stable, reliable electricity. Because without it, the nodes are not going to function. And here's something worth noting. When DLTs run on consensus mechanisms like proof of work, the energy consumption can get very high. That is why there's growing attention on energy sourcing, on sustainability when deploying these systems. And lastly, when it comes to security on the user side, many prefer using, physical wallets, either hardware devices, either paper-based storage to keep their private, to keep their public keys safe. These wallets then become part of the broader hardware ecosystem that supports DLT. So to sum up, what do I want to say? That permissionless DLTs gives everyone access, but at the same time, they require stronger hardware, reliable power, and secure key storage to function effectively. Now let's touch upon the business aspect of DLT. This is an equally important piece, I would say. And this is where your people, your organizations, your capital is going to interact to keep your technology very efficient, to actually give it the real world impact. Starting with the users, At the core, we have users. These are actually the individuals, companies, the entities who engage with DLT through, let's say, different applications, let's say, different products, different services. Their goal is simple: to achieve a purpose, like let it be transferring assets, managing data, executing smart contracts, and these are all what your users are here in are in your system here for. Then with the next one. Next one goes by investors. They are the ones who actually are responsible to provide the financial fuel to build the ecosystem. Of course, they are actually motivated by profit because they're they're the investors. But many investors do care about the values, such as being sustainable, solving economic challenges. So, investment in DLT often blends financial incentives with broader social missions. Then also you have your block producers, the full validating nodes we've already studied before, right? In proof of work, these are the miners. Their job is to solve complex computational puzzles, and in return, that they're incentivized, rewarded with crypto. And block producers are actually critical because they keep the network running securely, they keep the network running fairly, while also earning incentives for themselves. Then your corporations, your developers, although it's not detailed out here, but it's important to note the role of corporations, the role of developers. Corporations adapt and integrate DLT into their business models, into their existing business models, I'd say, while developers are the one who are actually developing it, innovating it by creating the applications around it, creating smart contracts around it. So the business ecosystem is a blend of users, investors, producer, corporations, your developers, each of them in the system with different motivation, but all of them working together to keep your DLT, distributed ledger technology, alive and thriving. With this, yes, corporations and developers, which we hadn't seen before in no greater detail, we'll see it here. So corporations adopt DLT to improve their business operations and create value for the customers, because if you're putting in blockchain, everything is there. And if you're telling your customer that everything is so transparent that it is always going to be there, you're not actually selling commodities, you're selling trust, you're selling stories. So they build platforms where end users can transact more easily, interact efficiently with other stakeholders, save time, save money. On the back end, corporations benefit from enhanced data security, integrity, and transparency. But it's very important to remember that corporations must use DLT in compliance. In compliance with what? In compliance with the laws, in compliance with the applicable regulations. Just because the technology allows certain operation doesn't mean every action is legally permitted. Make sense? Then your developers, creators, builders of the ecosystem. And these are the ones who build up your distributed applications, DApps, products, services that run on DLT networks. Beyond coding, they also provide ongoing technical support, the on-call supports, right? So in short, your developers are everything behind what is working, right? So in the business layer, corporations provide platforms, corporations adopt the technology, because if there's nobody to adopt, what will the developer do? I can keep on building up the product, but if there's no one who is actually, going to abide by that use case, we're actually going to use it, there's no sense. It's just a cost waste. Now that we've covered hardware, we've covered business layers, let's talk about the software aspect. This is the layer that powers your DLT application, that makes it functional. A software ecosystem is essentially a network of entities interacting within a shared market for software for services, while also maintaining relationships among themselves. In the context of DLT, this ecosystem includes all your applications, includes all your tools and protocols that run on the network. DLT applications can be written in a wide variety of programming languages: CPP, Java, Go, Rust, Solidity, JavaScript, Python, many more. And each language brings its own strengths, its own cons, depending on whether you're developing smart contracts, you're developing full nodes, you're developing decentralized applications, DApps. Importantly, DLT should be language neutral. That means as long as the software fully complies with the underlying protocol requirements and specifications, the choice of programming language should not matter. It's like you're sitting in an interview and you get a DSA question, you can solve it in any language you know, right? And this flexibility always helps you. This flexibility allows your developers to innovate without being restricted to a single techno stack, right? With this, let's just dive deeper into the software layer of DLT and understand how your applications are designed, how your applications are categorized. First, while DLT is your language neutral we're talking about, right? But each programming language has its own strengths, its own weaknesses. And developers, what they need to do, they need to carefully analyze what use case are they going to build up the application for and which language is going to best suit them. For example, let's say Solidity is often preferred for smart contracts on Ethereum, while CPP, Rust may be used for building full nodes for performance intensive systems. And then the applications. If I come to applications, your applications can be broadly grouped into three categories: financial, semi financial, non financial. Financial applications, anything that involves managing, that involves transferring money. Crypto, payment, decentralized finance solutions. Semi financial applications, these may involve money indirectly, but focuses mainly on your business processes, such as your contract execution, supply chain management, or your workflow automation. Non-financial applications, most open-ended category included, election voting systems, governance frameworks, data record storage, and digital identity authentication. To give you a sense of scale, there are there are tens of thousands of distributed applications already in existence. And developers, they're just creating up the new ones every single day. They're just spinning up new applications every single day. And the software ecosystem is constantly evolving. And that is what, in a way, making DLT such a dynamic, such an innovative space, uh, inviting more collaborators, inviting more developers into the space. So yeah, essentially, the software layer is where your ideas are turned into apps, they turn into your applications, and the right choice of programming language, the right choice in design approach determines how effective and efficient your applications are going to be. Last aspect of your ecosystem that comes with protocol development aspect. At this layer, the main players are your developers, the main players are your academia. Their focus is on designing and maintaining the protocols that govern how your DLT network operates. Because it is distributed, you don't have a central authority. So there have to be a community of people. There has to be a community of people who have come in together to have a protocol, right? So essentially, your protocol layer defines how cryptographic keys interact with the network, how your transactions are validated, and how your consensus is actually reached up in the network. So there are two main types of protocols that go with open source, closed source. Talking about your open source protocols, these are publicly available for anyone to download, to order, to contribute. Changes or updates to the protocol are typically accepted through community voting or via a responsible disclosure program. Open source encourages collaboration, encourages transparency, encourages rapid innovation. Then your closed source protocols, these are important protocols, right? And they're used by your private entities and they're accessible only to your authorized operations. In these systems, developers encode sensitive information and alter it locally before sending it to an aggregator. Closed source protocols provide your privacy, provide control, but at the cost of some transparency and community involvement. Because you cannot give everything, right? If you're keeping up a barrier, if you're keeping up a barrier from public, that is something that is telling that you're not transparent enough, that you're not community involved enough. But at the same time, it also tells that you have put up a proper constraint for privacy and for control. So in short, your protocol layer ensures the network functions securely, ensures the network functions reliably, whether through an open collaborative approach or a controlled private one. Developers and academic researchers are the architects behind these rules, shaping how your DLT ecosystem runs on which protocols. So, alongside developers, researchers and your academia play a crucial role in the DLT ecosystem, with their main job to educate, analyze, and evaluate. As private companies and open source communities, constantly release the new DLT software, new DLT applications, researchers step in to provide formal, unbiased peer reviews. They assess the technical, they assess the environmental, they assess the hardware, economical, political, psychological, sociological, and whatnot implication of the system. By doing so, your researchers help define the limitations, help define, risks of DLT. And yeah, while they also identify potential opportunities for the other people to come in and collaborate in the space. The insights they generate create new knowledge, informs developers, informs corporations, informs investors, users, essentially guiding the entire ecosystem towards more reliable, sustainable, and effective implementations. In short, while your developers build the network, academia ensures it's understood, validated, and responsibly applied in the real world. With this, if you have any doubts, please post them in the comment section. I think this video has been a little long, little over the time. But yeah, that's it. We're done with DLT ecosystem. We'll be starting up with smart contracts in the next video. So yeah, if you have any doubts, please post it in the comment section. Please use the G-forms attached. And yeah, if you liked the video, if you were able to extract something out of the video, just go in, subscribe to the channel because the playlist is still building up. Thank you. Bye-bye.